Hey kids, today we're going to learn about for loops. What's a for loop? Well, kids, it's just another type of loop in Java. It's usually used when you know how many times you want something to execute. It is often simple counter-controlled loops to do the loop body a set number of times. Kids, all this means is usually a for loop, as I like to say, are your counter loops. If you know you want to count up or down to something, this is usually how you want to do it. If you took APCSP with block programming language like App Inventor, you probably used the for loop. Kids, we didn't use App Inventor, so we didn't use it. If you have used a language like Scratch or Snap, you may remember the repeat block when you type in the number of times you want the code to be repeated, just like AP pseudocode repeat block. In fact, almost every programming language has a for or repeat loop. Again, kids, we didn't do this in APCSP. We didn't have that because we used JavaScript. And they had no real for loop that we used in their programming. And I know often in Scratch, in our basic programming class, we used a repeat block all the time. So this is going to be somewhat familiar to you because in a lot of ways, it's also a lot like the while loop. Over here, we have our statement. So if you had App Inventor, again, which we didn't, kids, well, that's what it looked like. Those we're going to be writing. Pretty much, kids, we're taking those 3 lines we had before, throwing them on one line. The 3 parts of a for loop. A for loop combines all 3 parts of writing a loop in one line to initialize, test, and change the loop control variable. The 3 parts are separated by semicolons. Each of the 3 parts of a for loop declaration is optional: initialization, condition, and change. But the semicolons are not optional. And here's what we got right here, kids. So again, we're just having our initializing. So this is again a lot like the while loop. We're going to test our condition, and then we are going to change the variable. And you can see down here, we have a little example of that. So for the integer x equals 3, while x is greater than 0, we're going to subtract a number, and then we're going to print that out. So these are just the 2 parts, and this is our 3rd part initializing it, and then we still print it out. So it's a lot like a while loop, kids. We have another amazing video here that breaks down the loops a little better. I am not going to watch it in this video, kids, but I highly recommend you take a minute and watch it. Here is the control flow diagram for a for loop. The code in the initialization area is executed only one time before the loop begins. The test condition is checked each time through the loop, and the loop continues as long as the condition is true. And the loop control variable is done at the end of each execution of the body of the loop, just like the while loop, kids. When the loop condition is false, execution will continue at the next statement after the body of the loop. And if you remember, this looks pretty familiar from the while loop, kids. Well, it is. So we have our 3 parts there. As long as it's true, it's going to keep going or initializing. When that condition is false, just like a while statement, we move on to the next one. Here is a loop that contains a counter that goes from 1 to 5. Can you change it from 2 to 10? Well, let's take a look at our code here. We have our normal method, we have our for loop, and then we have our system printout count. In our for loop here, we start at 1. We're going while the count is less than 5, we're going to add 1 to it. So it should keep going. Well, if we want to go from 2 to 10, well, I know I need to start to count at 2 now, and I don't want it to equal 5. I want it to count up to 10. So as long as the count is less than or equal to 10, well, then I want it to keep rotating around. I think that's it, kids. Let's see if I'm right. 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that prints out exactly like they wanted there. Like I said, kids, not that different from the while loop. Here's a while loop that counts from 5 to 10. Run it and see what it does. Can you change it to a for loop or run your loop? Does it do the same thing? Let's take a look at this code first. We have an integer count, which is equal to 5. While count is less than 10, we're going to print off count and then go plus plus. Well, let's see what happens. It counts from 5, 6, 7, 8, 9, 10. So it looks like this count starts at 5, prints to 10. It's going to print off whatever the count is and then go to the next one and print it off. We have a while loop here. We want to change this to a for loop. Well, let's start moving some stuff around, kids, because really all this stuff is just the same things, just in a different order. So I can get rid of this while, kids. And now I just need a for loop, right? And I need a set of parentheses. So an integer count is going to be equal to 1. We're going to have our semicolon. We don't need this set of parentheses. We do need another semicolon. And then we need to close off that whole part right there. No semicolon after it. And then we're going to print off what's in our system. All right, let's see if this works, kids. We printed off a 5, 6, 7, 8, 9, 10. Looks like we did everything that Runestone asked us to do. And all we did was we took those different parts of the while loop, moved them around a little, and that created our for loop. Note, 2 common patterns in for loops are to count from 0 to a number using the less than, or count from 1 to the number including the number using the less than or equal to. Remember that if you start at 0 using less than, and if you start at 1, use the less than or equal to. The 2 loops below using these 2 patterns both run 10 times. The variable I for index is often used as a counter in the for loops. This is just showing the difference of using a less than and starting the counter at 0, and less than and equal to and starting the counter at 1. Again, both of these run 10 times, kids. So just remember how you're coding it up. Something simple like this can often make your program do crazy things. Remember, that's a logic error because it's running like it should, but we're getting unexpected results. So just keep in mind. Let's take a look at this code here, kids. So what's really happening here? Well, this statement right here is initializing the variable. So we're starting off with 3. So keep this in mind. This would be just like a while loop. And remember, we print off what we want, then we add next to the number. These things still apply. So we're still initializing it. And this statement really sets the variable before the loop starts. So remember that. This part right here, part number 2, defines the condition for the loop to run. It must be less than 8. If that condition is true, the loop will start over again. If it is false, the loop will end. So that's just the testing part. Our third part just increases the value each time the code block in the loop has been executed. So how does this run through? Well, again, it initializes first, then we jump into our loop. So I equals 3 is going to print off first, kids. So just remember that. That gives us a big hint there. It's really between these two. So once we initialize, now we're going to run through the loop. So we're printing off 3. Once we get back through, is a 3 less than 8? Yes, it is. Once it prints out, kids, we're also going to be increasing it 1 every time it goes through the block. So keep that in mind. So that is 3. Number 4, we're starting now with 4 because we're in the loop. Is 4 less than 8? It is. So we're going to print off 4. We're going to go up 1 to 5. Is a 5 less than 8? It is. So we're going to go over here. We're going to print that off. We're going to go up to 6. Now, is 6 less than 8? It is. So we're going to print off 6. increase 1, and go up here to 7. So we printed off 6 now. Is a 7 less than 8? It is. So we're going to print off 7, and we're going to increase 1 to 8. Is 8 less than 8? It is not, kids, because we're not using the equal to. So we're out of that loop. So all we did was we print 3, 4, 5, 6, 7. We did not print 8. So the answer should be D. Let's see if I'm right. Ooh, there we are, kids. So that's how we got that one. Keep that in mind. That is a very common mistake I see with these for loops. Just remember, kids, it executes once before it goes into testing the for loop. Here's another example of almost the same thing here, kids. We have I, and then we have, while I is 1, and as long as it's less than 10, we're just going to go up 1. So where do we start printing off at? Well, again, kids, we execute the loop once, so we're going to print off 1. We're already down to 2 answers. Once we go through once, we're going to increase it. So the second loop is now going to be a 2. Is a 2 less than 10? It is. Oh, we're going to go print that off, increase 1. 3 is a 3 less than 10. It is. Print that off, increase 1. 4 less than 10. Yes, it is. Print that off, increase 1. 5 is a 5 less than 10. It is. Print that off, increase 1. 6, 7 less than 10. It is. Increase 1. 8 is 8 less than 10. It is, kids. Print that off, increase 1. 9 is 9 less than 10, kids. It is. I'll print that off, increase 1. 10 is 10 less than or equal to 10. Well, it is, because we have the equal sign there. We're going to print off 10, increase it 1 to 11. Is 11 less than 10? It is not, kids. So we should print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Started at 1. We're equal to this. You'll see a pattern there, kids. So it should be C. Ooh, maybe we're going to put that pattern to a test. How many times is the following method print in the asterisk, kids? We have our for loop. Integer I is set to 3, while I is less than or equal to 9. We're going to increase 1 and then print out the number I. Well, kids, how many numbers are there between 3 and 9? We have 3, 4, 5, 6, 7, 8, 9. That is 7 numbers, kids. 7 between it should run 7 times. There we go. We're right. The following method has the correct code to print out all the even values from 0 to 10, but the code is mixed up. Oh no, kids. Drag the blocks from the left into the correct order on the right and indent them correctly. Even though Java doesn't require indentation, it is a good habit to get into. And kids, please believe me when I say it is. Do not become like me and have horrible bad habits. You'll be told if any of the blocks are in the wrong order or if they're not indented the correct way when you hit click me. I think we can do this though, kids. What do we got here? We have our system print off. We have an end of our method. Looks like we have our for loop, our old friend public static void, and then an end for the for. Well, I know this is first, so that should be on the first indentation. I know the next stuff is going to be my for loop. I want to move that over 1. And then I definitely want to move my printout 1. I probably want to end my for loop next, and we're going to go back in the same part there. And then my giant method closes my top method here. That should be the order. Let's see if I'm right, kids. Hey, it was. Decrementing loops. You can also count backwards in a loop starting from the last number and decrementing, or just decreasing, kids, down from 0 or 1. All 3 parts of the loop must change to count backwards, including the test of when to stop. For example, for int equals 5, I is less than 1, I subtract 1 counts 5 down to 1. What do you think will happen when the code runs below? How would it change if you changed line 11 to initialize i's value to 3? Let's see this code here, kids. Uh-oh. This looks like an adult song, my friends, but with a kid twist. You know how I like my cheesy songs. Let's hope we don't get any YouTube slashes on this one. What do we have here? Well, we have, it looks like 3 strings, bottles of pop on the wall, bottles of pop. Take one down, pass it around. And it looks like we have a loop 5 times. And this is my comment telling me that. And it says we're going to initialize at 5 until we hit 0. We're going to decrease. So we're going to go 5, 4, 3, 2, 1. We're not going to go 0 because it's not equal to. What are we going to do then? We're going to print off I plus line 1, I plus line 2, and then line 3. And then in this one, we are going to go down and do I minus 1 plus line 1, and then print off nothing. Well, that's what should happen, kids. So what I should get is 5 bottles of pop on the wall, 5 bottles of pop, take one down, pass it around, and then 5 minus 1 is 4 bottles of pop on the wall. And then I should get nothing. Well, let's see if that happens, kids. Well, before I hit this, it should count all the way down, but I'm not going to sing all of that, kids. Let's just see. That looks like exactly what I said. We go 5, the number, and we keep going down. So we basically printed off this one right here, prints off this loop here. 1, 2, 3, 4 lines. 1, 2, 3, 4 lines right there, kids. So that's what we get right there. What do we have to do here? We want to initialize this at 3. Well, if we did that at 3, kids, so we want to go 3, we should get now 3, 2, 1 printed off. So we really should just get, kids, these 3 lines right here. Well, let's see if that's what happens, kids. And there you go. We have our song printing off just like that. And again, because our last line here is going to have us at 1, 1 minus 1 is going to be equal to 0. But right after that, kids, we're going to jump out of the loop because 0 is not greater than 0. So that's why we're going to get this bottom line printed off here and not the rest. Pretty cool, kids. Pretty fun. And if we had more time in this video, I would sing the entire thing to you starting at 99. But be glad I'm not, my friends. We have this little piece from above just to tie it all together, kids. The method printPopSong prints the words to a song. It initializes the value of a variable I equal to 5 and then checks if it is greater than 0. Since 5 is greater than 0, the body of the loop executes. Before the condition is checked again, I is decreased by 1. When the value in I is equal to 0, the loop stops executing. Our next activity here, can you make the loop count backwards by 2s? It should print 5, 3, 1. Remember, change all 3 parts. All right, kids. We have our little method here. For our integer count, we're equal to 1. While the count is less than 5, we're going to add 1. Well, kids, if I hit save and run, this should go 1, 2, 3, 4, 5. Let's see if I'm right. 1, 2, 3, 4, 5. So it did, but we need a 5, 3, 1. 5, 3, 1. What do we need to change? Well, let's start with the count. We want it to be 5, our top one, right, kids? And we don't want the count to be less than or equal to 5, right? We want it to be less than or equal to 0. So we should go down to 0. And we don't want the count to add 1. We want it to subtract, right? Kids, we got to remember all the way back to Unit 1 how to do this. Remember our operations, minus, equal, and then we want the number, and that is going to be 2. Don't forget our parentheses there. So minus equal 2. It'll subtract 2 off each one. When I hit save and run now, we should get 531. Let's see if I'm right. 531. So that's how we did it, kids. Remember, change all 3. Turtle loops. Do you remember when we used the turtle objects to draw shapes? I do, kids. That was super fun. To create a square without loops, we had to repeat the code, go forward, and turn 90 degrees to the right 4 times, like below. Can you change the code below to remove the repeated lines of code and use a loop to draw 4 sides of a square? Do you notice the code becomes a lot shorter? You should only need 1 forward and 1 turn command in the loop. Whenever you find a repeating code, try to use a loop instead. Kids, we're going to jump over to a Replit for this because ultimately you're going to be doing it there anyways. All right, kids, we are over here in Replit. What we have to do is we have to make this repeat and make a square. So let's go ahead and run and just see what happens here first. Looks like we get a little L. This code isn't even complete to give us a square, kids. We would need a couple more codes for that. We'd have to go turn right, turn forward, turn right, move forward, turn right. Kids, we're here to do a for loop though, so we won't want any of this stuff. We can use a little bit of it though. In fact, all we really need is just these 2 commands. So let's do a for loop, kids. How are we going to do that? Remember our 3 parts. So we're going to do for. Make sure your caps locks are off. Remember, this is all going to be inside that code. What was the first part? Well, the first part is we want to initialize our variable, right? So I'm going to do a new variable, and let's just call it side, each side. And we're going to start our sides off at 1, kids. Next part, how many times do we want the condition to go? Well, I want it to go 4 times, right? So we want it to be greater than or equal to, or less than or equal to 4. So it should go 4 times. And then we got to cycle through the loop. So we want to go side plus plus. Don't forget we need some quotes here, kids. We need to enclose this. Do a little tabbing. Whoops. Kids, everything's going crazy here. There we go. Looks a little better there. Let's go ahead and run this and see if we get a square, kids. Well, there's my little turtle friend. A complete square. 2 lines of code. Technically, we ended up losing about 2 lines when it's said and done because we still have to account for all of this. We ended up with 1, 2, 3, 4, 5. The total square would have been around 8. So we did save some lines, but if it was going to be more complex, we would have definitely saved a lot. Well, that's how we make a square, kids. Let's jump back over to Runestone. Ooh, we got another programming challenge here, kids. Looks like we're going to do it in a Replit as well. We're going to have Yertle draw an equilateral triangle using a loop. How many times should the loop run? Remember, it ran 4 times for a square. How many for a triangle? How many sides does a triangle have, kids? What angle should you use for the turns? One way to figure this out is to notice that a complete shape, all the exterior angles, should add up to 360 degrees. One way to figure this out is to notice that a complete shape, all exterior angles, should add up to 360 degrees. For a square, 4 times 90 adds up to 360. Kids, I think the over obvious hint here is they want us to take 360 and divide it by some number. For a triangle, I'm going to assume that's 3. Have Yertle draw a pentagon using a loop. A pentagon has 5 sides. What external angle should you use for the turns? Remember, they add up to 360 degrees. Kids, that's another hint. I think this one, we're just going to take Yertle 360 divided by 5. Create a variable n that holds the number of sides for any polygon and use n in your loop for the sides and to calculate the angle to turn. Can you have the loop draw a variety of shapes by just changing the value of the variable n? Well, the power of abstraction, kids. Can you draw a 9-sided nonagon? Note that if the turtle runs into walls, it stays there and will mess up the shape, so you may have to move the turtle or go forward a small amount. Very interesting. Use a for loop to draw a triangle, then draw a pentagon, and then change it to a polygon. So there's our instructions again. Kids, we're going to do this over in Replit, so I will see you over in Replit. All right, kids, let's take a little look here at our code. Looks like we have our old world code back here. Remember this all the way back to Unit 2, kids. So it looks like we're creating a new world that is 300 by 300. We're creating a new turtle, Yertle. Where's the Yertle going to be in the new world? Yertle's going to move forward, turn right, move forward. So this actually looks a lot like the code from before, kids. Let's do our first. Let's go ahead and let's get rid of this, kids. And let's start creating some new Yertles. And I'm going to rename Yertle, and I'm going to name it Triangle, because that's just going to help me with stuff here, kids. Let's move our comment up here to, this is going to be our triangle code. Look at that, kids. Even almost spelled it right. There we go. So that's going to be our triangle code. And, well, what do we want to do for that? Well, I think for this turtle, we want to do a for loop, right? So we want to go for, and then we have to start building our loop again, kids. We're going to have an integer, and I'm going to call this one side again. And side is going to be set to what? 1. We want it to be 1 initially. And then we have to move how many times through our loop? Well, we want side to move to either greater than or equal to 3. And then every time it goes through, we want side to go up once. What do we want to have happen? Well, let's put our loop here. We want to have triangle. Kids, this is going to be a problem. I'm going to spell this wrong all the time. We're going to have a triangle go forward. Let's say 100. Don't forget your semicolon, kids. And then we are going to turn. Remember the huge hint, kids. We're just going to do 360 divided by 3. And that's it. Let's go ahead and run our code and see if this works. Oop, doesn't look like it's running, kids. I also noticed this should be sides is less than or equal to 3. That's probably our problem. Let's try this again. There's our triangle. Look how nice, kids. I think we need to move our turtle over, though, a little, like they said, because we're going to have to draw some crazy shapes here. I'm going to just increase the size of our code here. I'm going to go 600 by 600. And let's remember some old code, kids. Let's move triangle. Let's pen up it first because we want to move it, right, kids? And where do we want to go? We want to move it to, we'll do our move to, remember that one. We have to give it an X and Y coordinate. So let's say 100 by 200. And we'll have to put the pen down now. And let's not leave our colors up to chance, kids. What color is a triangle if you could picture it in your head? Well, kids, to me, it'd probably be green, right? If a triangle is any color, it'd be green. I have no idea, kids. We'll just say it is. So set color, color green. Everything looks good there. Let's just try this out. Actually, let's try a different color just to make sure. Let's go color blue. Let's stop and run it. Make sure our code runs before we move on, kids. Well, kids, looks like it's working there. Let's try making our next little shape. And what do you have to make? A pentagon. So let's go over here. Let's comment this out. Pentagon. Well, kids, what do we have to do? We have to create a new instance, right? So we're going to make turtle pentagon. Oh, this is going to be bad, kids. I can just fill it. Where do we want that? We want that new turtle to be in our turtle world. Oops. Gotta finish spelling it though, kids. Right there. And let's just get our code working first before we go anywhere, kids. Let's go through and what we have to do. Pretty much the same thing up here. So we're going to do another for loop, kids. So we're going to go for, and we're going to do another integer. And this time, let's see if we can do side 1. We'll just call it something a little different. Actually, side P for pentagon. And we want the sides equal initially to 1, right? Same thing. And we want this to run while the sides are less than or equal to what? Well, a pentagon has how many sides, kids? 5. So we want that to 5. And then we want, oh, don't make sure we're using the same variable here. And then we want side P to add through it. And what's going to add forward? Well, kids, don't forget your brackets. Pentagon dot forward. We are going to go maybe, let's do 50 on this one. This might get a little large on us, kids. And then we're going to do pentagon dot forward. Oops, turn. And this is going to be a 360. I think we can just do divided by 5 again, kids. And hopefully, when I run, I should get 2 turtles here, kids. Let's see if I'm right. There we go. We got our little pentagon. Again, it's kind of up where we need to draw the next one at. Let's move it down here. So let's go over to our little turtle here. First, I'm going to copy this, kids, because I don't want to spell this out, nor do you want to hear me this over again. So we're going to go pen up. Then we're going to move to, where do we want to move to? Well, that's X and Y. So our X is 100. Let's move it over to, let's say 500. And let's go, well, let's see what 500 does, kids. I think, no, let's go 400. Like that. Then we got to put our pen back down. And let's set our color to, why not? If a pentagon was any color, what color would it be? I'm going to go color dot red. And that should take us right there. Let's run it one more time just to make sure our codes are working before we move on. There we go. Put us down there. It looks pretty good, kids. I'm happy with it. We still got one more to go. So we have to do our polygon. So let's comment this out. Polygon. What do we have to do first? Well, let's create our new turtle. We'll call it a polygon just like that. Where's that turtle going to go? Well, that new turtle is going to go in our world we just created right there. So we have our turtle polygon. Well, let's talk about this loop for this one, kids. If you remember, what we have to do for this polygon is we want to create a variable n that's going to be used to calculate how many sides there are. So we're going to make a polygon we can change the numbers towards. So we're going to need a couple of things on this one. So before we get to our for loop, we have to add a new integer here. And my integer, n, is going to be equal to whatever number. I think we wanted to do a nonagon, so I think we're going to start off with 9 here, kids. So let's set it equal to 9 initially. We can set it to anything, really, because we can change this. And let's build our loop now. So we need our for loop just as before. And our integer is going to be side g, polygon. I hear G in there, kids. And our sides are always going to start at 1. But now side g, kids, that is going to be less than or equal to whatever n is going to be. That means if I want 9 sides, it should run 9 times. Same thing though, I still want it to progress through my loop, side g plus plus. We need some brackets, kids. And this is going to be just like it was above. We're going to go polygon dot forward. This one, we'll probably have to make it pretty small. Let's go 50 again. And then we need a polygon turn. How do we want it to turn? We've been doing 360 divided by. Let's pass our variable again, kids. 360 divided by n. And I think that should work for us. Let's go ahead and run our code and see if it works. Ooh, I love that purple, kids. Our little red turtle in them is starting to get in a little fight there. Let's move this turtle down. And let's move it down in the Y. Let's move this down to 500. Let's see what that looks like. That looks a little better. And there we have our polygon. And we can make it any shape we want now. So if I come down here and I change this now to 15, stop and run, I get a shape that has 15 sides. Starting to look like a circle though, kids. Pretty neat little program. And that's how we would code up a multi-sided polygon. I think that's everything they wanted for this programming challenge. Let's jump back to Runestone and see if they want anything else. Well, kids, that looks like that's it for this lesson. We just have our summary here. There are 3 parts for a loop header, the initializer, the test condition, a Boolean expression, and the increment or decrement statement to change the loop control variable. In a for loop, the initialization statement is only executed once before the evaluation of the test. Kids, this one's important here. In the for loop, the initialization statement is only executed once before the evaluation of the test Boolean expression. The variable being initialized is referenced to as the loop control variable. That's what we saw above. Just saying the first number runs through. So if it starts with a 3, well, that's where we start, kids. In each iteration of a for loop, the increment or decrement statement is executed after the entire loop body is executed and before the Boolean expression is evaluated again. So remember that. A for loop can be written into an equivalent while loop and vice versa, kids. And that's it for this lesson. Pretty fun if you ask me. As always, if you have any questions, come see me. Otherwise, kids, I'll see you on the next video. See you later. Bye. Bye.